Well, let's see how we can connect the reference angles that we just talked about with the special angles that we talked about previously. I want to know what is the exact value, or what is the function value for the cosine of negative 240 degrees. So let's come in here and let's sketch negative 240. Negative 240, when I rotate around, starting on the x-axis, we rotate clockwise. If I go 240 degrees, I'm going to end up here in the second quadrant. So what I want to know is, what is this value in here? And I can figure that out. I can figure that out by finding an angle that's coterminal with negative 240 that's positive. So if I was thinking, well, what is coterminal with 240? So we've done that before. We know that 360 minus the 240, that's going to end up giving me 120 degrees. So I've rotated 120 degrees in the positive direction. But what I'm interested in is not the coterminal value, but the reference angle. So the reference angle, again, is that small acute value that is located between the terminal side and the horizontal axis. So I'm going to take 180 degrees minus 120, and I find out that that is, in fact, 60 degrees, which is the reference angle. So now that I know what the reference angle is, think back to those special triangles that we talked about. We had a 30-60-90 triangle, and we had a 45-45-90 triangle. So if I were to sketch my 30-60-90 triangle here, I know that the number 1 goes across from the small side of 30. I know that 2 is the hypotenuse, and that leaves me with the square root of 3 falling across from 60 degrees. So what this question is asking is, if I know what the cosine of 60 is, then that's exactly the same answer as the cosine of negative 240. So let's figure that out. The cosine of 60 degrees is going to be, so if this is the angle that we're looking at here, cosine is adjacent over hypotenuse, so that would be the square root of 3 over 2, the square root of 3 over 2, and what we're finding by using reference angles is that the cosine of 60 degrees is exactly the same thing as the cosine of negative 240, because I'm in the exact same location. So therefore, the cosine of negative 240 degrees has to also be the square root of 3 over 2. Oh, but there's one thing I forgot. Where am I at? This is where we need to make sure that we have the sign right, positive versus negative, on a cosine. If cosine is in quadrant 2, then my answer has to be negative, because the only values that are positive in the second quadrant are going to be sine and cosecant. So cosine has to be negative in the second quadrant. So that's how we can use reference angles to be able to identify an exact function value. Let's look at this last one here, 675. The tangent of 675. So 675 would be, if I went around the circle 1 plus more. So 1 revolution around is 360, 2 revolutions would be 720, so I'm not quite there, so I'm going to stop somewhere over here, what I believe to be in the fourth quadrant. So if I were to take 675 and subtract 675 from 360 degrees, I would end up with 315 degrees. So 315 degrees is coterminal to 675. That's not what I'm interested in. Again, I'm interested in this small little reference angle right here. So I'm going to take 360 minus the 315, and I find out that that little reference angle is in fact 45 degrees. So now I can use my 45, 45, 90 triangle, which is a 1, and a square root of 2. And I can say the tangent of 45 degrees it's got to be equal to, and let's just pick one of these because they're both the same. Let's just pick this angle at the top. Opposite over adjacent, so 1 over 1, which is just going to be 1. So if the tangent of 45 degrees is 1, then the tangent of 675 has to also be 1 because they are in the same location as you can see from the picture below.